Good afternoon. Welcome to course Thermodynamics of Materials. And today we are into lecture 109 and 110. This was last test discussion. Just I need to remove this. Today we will discuss activity coefficient versus composition relationship for multi-component systems. So before this, today we will cover first of all this multi-component system, activity coefficient versus composition relation. Then we will pick up how to experimentally find interaction coefficients. So this is actually our major task today. So so, this is we are all set. Let's start. The quadratic, the title is today's title. Today's title is quadratic activity coefficient versus activity coefficient versus composition relationship in a multi-component in a multi-component component, which is in this case quaternary system, namely A, B, C, D. This is our initial job. We will learn this for multi-component. So far we have considered binary system, AB, regular solution or modified regular solution, binary. But today we will consider straight away into multi-component system ABCD. Then we will try to extrapolate to 5-component system, or maybe we will actually see how it will reconcile with the binary or further matter ternary systems. We will do this. So first of all, I have to give you some introduction about this job. Okay. the derivation actually I did this derivation. I did this derivation myself and I published this work in a paper that I reference I am giving you. So this derivation, the derivation of this, the derivation the derivation of this relationship, derivation of this relationship of this relationship which is direct, which is direct self-sufficient self-sufficient and exhaustive, self-sufficient and exhaustive exhaustive has been authored by myself, is namely okay, Dinabandhu Ghosh, and the reference will be convenient, a derivation a derivation a derivation of a quaternary of a derivation of a quaternary derivation of a quaternary quaternary of a of a quadratic the quadratic activity coefficient versus composition relationship composition relationship in a quaternary system in a quaternary system in a quaternary system ABCD. This is this ABCD, okay, CD. Metallurgical, the journal is Metallurgical and material transaction trans B transaction B 2010 volume volume 41B page 1274 to 1283. This is the reference. This is reference. Okay. The outline the outline the outline of this of the derivation is outline of the derivation is given below, is given here, is given here, given here. Okay, using a Maclaurin, using a Maclaurin, using a Maclaurin Maclaurin series expansion, Maclaurin series expansion, Maclaurin series expansion, the Raoultian activity, the Raoultian activity coefficient, activity coefficient, Raoultian activity coefficient, ln gamma I, ln gamma, ln gamma I of each component, of each component, each component is equated, is equated with a quadratic, with a quadratic, with the equated with the quadratic expression of, quadratic expression of mole fraction, mole fractions xi symbol xi involving involving the activity coefficient, activity coefficient at zero concentration, which is namely gamma I 0, which is gamma I 0 activity, and 9 interaction coefficients, and 9 interaction, 9 interaction coefficients, which is actually symbol epsilon, epsilon interaction coefficients, I'm sorry, and 9 interaction coefficients equated with this. What is it is? Using this series expansion, the Raoult's activity coefficient of each component is equal to, subsequently with the help of a, with the help of a, help of help of a, help of a Gibbs-Duhem equation, Gibbs-Duhem equation, Gibbs-Duhem equation, followed by a comparison of, followed by a comparison of coefficients, of coefficients coefficients most preceding 9 times 4, 9, that is 36 interaction coefficients see 36 why? See here 9 coefficient for each component. So 9 for A, B, C, D. So 4 components. For each there are 9 interaction coefficients. So it is 9 times 4, 36 interaction coefficients. Most of them, what has happened, are eliminated. Most are eliminated. Leaving behind only leaving behind behind only and only three cell and three cell and three ternary and three ternary and three ternary interaction coefficients. Action coefficients. So only 6, 3 and 3, 6 interaction coefficient instead of in place of 36. By equality, by actually the equalities of the remaining 27 with the 6, 3 means 6 remaining 30 can be equated with this 6 can be shown to be equal to this. So they are related. They can be expressed in terms of these 3 cell and 3 ternary interaction coefficients. So 6 in terms of 6 we have. So it will be much easier, simpler than it was at it than it seems initially. So this okay. So this okay. Which are enough? Sorry. Which are enough? Which are enough? Which are enough to express the activity coefficient activity coefficient versus composition relationship relationships for the solutes B, C and D, B, C and D, as well as for the solvent A. Solvent A. It may be noted here. It may be noted here noted here, noted that the relationship, noted that the relationships are in accordance with the principle of modified regular solution behavior uh, regular solution behavior behavior regular solution behavior discussed previously maybe in the last class, maybe, okay, discussed previously, maybe the last class. So the final results are given below. That's it. So this is the introduction of actually what we'll do. The procedure. The procedure is this given here. This is the full paper is given here. Is reference given here. So actually we start from Maglaurin's series expansion for ln gamma I for each component, like ln gamma B, gamma C, gamma D in in terms of Maglaurin series expansion, in terms of composition and interaction coefficients. So involving activity coefficients is gamma 0 and interaction coefficients. Subsequently, we'll apply Gibbs-Duhem equation as in the previous cases, Gibbs-Duhem equation. Then that, and also comparison of coefficients like say x's, x squares, etc., xa, xb, etc. So this comparison with the okay, which is see where is it is subsequently with the help of and followed by comparison of coefficients. Then most of this 36 9 into 4 9 into, because there are 9 interaction coefficient and another is gamma I0. So 9 interaction coefficient times 4 components, 36 interaction coefficients are eliminated, most are eliminated, leaving behind only 3 self, like say actually I tell you what, EBB, E, self is what is epsilon BB, epsilon CC, epsilon DD. These 3 self, and what are the 3 ternary? Epsilon BC, epsilon BD, epsilon CD. Just 6. And of course, there will be a gamma B0, gamma C0 and gamma D0, which is easy to follow. Okay. So this then we will have the expressions, final expressions of ln gamma B, gamma C, gamma D, and as well as gamma A in terms of compositions and these 6 interaction coefficients can be obtained, and we will give the results only here. Next the results, and remember this follows the principle of modified regular solution behavior means this relationship are valid up to a certain solute concentration, say 30%, 40%, 20%. I gave a range 16 to 40 perhaps or 50, not beyond that. But this is good enough for our job, for our work. It is unlike regular, which is applicable for the entire domain, entire composition domain, like XB is 0 to XB is 1, full range. But these are limited range. The solute actually up to certain concentration of solute, that is the modified regular solution. We discussed at length. So this has to be considered. This has to be considered because this is practical. This is actually followed. Regular solution may be little bit idealistic. Okay, it is actually tall order. It's difficult. It is actually it is not so expected to have this solution behaving the regular solution over the full range. The quadratic relation over the, what is this? That the relation, Margul's relation is valid over the entire range. That is too much of expectation, maybe. That may not be observed, may not be practical. So we have got the modified form where these equations, so originally it is Margul's equation, they are considered valid over a certain solute concentration range. Okay, and this concept has been used, and this is actually now actually we consider generally use this concentration. A regular solution will be a special case when the activity coefficient composition relations holds good for the entire composition of the solute. Means XB is 0 to XB is 1. Okay, so note this. So this is quite practical to consider this modified regular solution behavior, and the results now actually well given. Okay, so now the results. First, for the quaternary system, A, B, C, D. First one, quaternary system A, B, C, D. The results. One by one I am giving you ln gamma B. Ln gamma B is ln gamma B0 plus gamma B0 plus epsilon BB. Okay, check this. It's okay. Everything is okay. Looks fine. Fine too. Okay. Actually, I was actually initially rubbing off. That time I think if there was any. It's okay though. EBB, sorry, XB minus half XB square. This fairly lengthy though. Okay. See, this is plus. So you check 1 hour 50 minutes. Check first. Then never plus E epsilon. I'm sorry, epsilon. This is actually E will come later. That is also interaction coefficient, but later after we introduce Henry standard state, all alternative standard states. Now epsilon BC will be it is minus half x square plus epsilon BD minus half excuse me, xt square This is the plus plus epsilon BC is what? XB minus XB XC. I'm sorry. XC, I'm very sorry. XC minus XB XC plus epsilon BD XD minus XB XD plus epsilon CD. CD is minus XC XD. Call this equation 1. Let me check if it is correct quickly. Oh, sorry. Actually, EBC has been repeated. So this is actually wrong. This is ECC. I am very sorry. This is cell. This is cell. This is self. These are ternary. BC. And A is there. ABC. ABD. ACD. Ternary. These are ternary. So this is okay. EBC. XC minus XD minus and minus XC minus XD. Okay, fine. CD. Okay, good. Next is ln gamma C. Is what? Start similarly ln gamma C0 plus E epsilon BB minus half XB square. See here how many? See here 1, 2, 3, 4, 5, 6. 6 interaction coefficient instead of 36. And of course this is gamma B0. What is it? That is activity coefficient at 0 concentration. So similarly here, EBB, you will see these will be repeated. These 6 will be repeated to express ln gamma B, ln gamma C, ln gamma D, and ln gamma A. Just follow me. EBB plus epsilon BB, epsilon CC is XC minus half XC square, plus epsilon minus half XD square, okay, plus, start here, epsilon, okay, CC, BC, epsilon CD. Epsilon CD is what? XD minus XC XD. Just if you follow the pattern, you can get this. Very system is there. There is a pattern there. There is some regularity about this. This can be followed easily. Easy, just if you are careful. ECD plus 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 ECD plus EBC XB minus XB XC. Here you have to note this. Note EIJ is epsilon ij is epsilon ji to be proved later. We'll prove this later. Epsilon ij, epsilon ji. That is, this is actually what is actually the effect of, what is this? Effect of J on gamma I. And this is effect of I on gamma J. See? So later on, okay. I'm sorry, actually, if I stop, this happens. So we can write here EBC, epsilon BC is as good as epsilon CB. No, okay. That is, what is this? The effect of C on ln gamma B. And what is this? Effect of B on gamma C. Okay. This actually, we call this is what? D ln gamma B over del XC at constant XB is 0, XC is 0. This Maclaurin series, okay, this whole full paper you can go through. This is actually, and similarly, this is what? D del ln, tell me, gamma C by del X B, effect of B on C, on gamma C. And again here you should write this XC is 0, XB is 0. In fact, I will today show you, today itself, how to measure this, how to experimentally find this, okay, later on. So this is the noting, careful, so that this may help you, okay. But this will be proved later on, okay, when after we have introduced alternative standard state, Henrian standard state. Okay, so ECD, EBC plus what? What is this? C, it is about C. ECD. ECD is already there. Okay, EBC. Yeah, I'm very sorry. It is now EBD. Is what? EBD minus XB XT. This is the equation second. Second. Okay. Okay. Second. What is the third? ln gamma t. Ln gamma t is what? Achha, before this, let me check this. Let me check quickly if it is correct. Otherwise, we will be in trouble later on. EBB ln gamma d is what? Ln gamma d 0 plus, right, epsilon bb minus half xb square plus epsilon cc minus half, this is xb square. This is xc square plus epsilon dd is what? xd minus half xd square. Then take up the ternary one. So what you consider first? E. Okay. Achha, let me take what it is written here. Here, first of all, EBD ECD. EBD. Actually, this you may consider epsilon BD is epsilon DB. Follow this or follow this. Epsilon DB, what is this? Is what? XB, okay, okay, XB minus XB XD, okay. Next is epsilon CD is what is actual expression XC minus XC XD, and the last is what plus epsilon, what you call it, okay, epsilon BC 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 is what minus XB XC. Call this equation 3, 1, 2, 3, and still another equation is what? I have to remove this. I have to remove this. Eh? Okay, if we want to save this, want to retain this. Next is solvent, Ln gamma A. These are solutes, B, C, D, Ln gamma A is what? Ln gamma A is what? Minus half. Let me check if this is correct quickly. Correct quickly. This is gamma D B is okay. Epsilon BD, XB minus XB SD is CD. Epsilon CD, XC minus XC XD plus EBC is A minus XB X is correct. Ln gamma A is what? Oh, ln gamma A actually. This let it rest for a while. Rest for ln gamma A is what? Minus half epsilon BB epsilon minus XB square minus half epsilon CC XC square minus half epsilon EDD XD square, and then what else? Minus, okay, epsilon XD square, okay, this is okay. Then you have minus EBC, let me check, minus EBC is correct. XB, XC minus epsilon BC, okay, BD minus epsilon BD XB XD, and last is minus epsilon CD XC XD. Call this equation 4. Just let me check quickly. Minus half EB XD square minus half EC minus half EDD. Next, this is first quaternary system over. You can check with the 6 only, 6 interaction coefficient, any of them, any, not 36, 6. By equalities they are out. They all remaining what 630 can be expressed, can be equated to this 6, can be shown to be equal to this, can be expressed in terms of this. So 6 finally, and the activity coefficients at 0 concentrations, namely gamma B0, gamma C0, gamma D0, these 3 obviously. So so this is, so you see 6 everywhere. So suppose you want to check here how many EBB 1, 2, 3, 4, 5, 6 interaction points each case. Now, so first is over, second will be now simpler. Second is simpler for the ternary system. Ternary system, what? Suppose you are interested in ternary system, not quaternary, ABC. So this is, instead of this, easier, what you will do? What you will do? The same relationship, only D is absent means XD is 0. XD, put XD is 0 into this 4 and you get the corresponding expression. So I will write two of them. So when you will follow, so how will you get this? We have to put XD is 0. Which equations? Okay, this is out in 1, 2 and 4. In equations 1, 2 and 4. Your ternary 3 will be there. So 1, 2, 4, 3 is out because there is no D. So if you do this quickly, what you get? I am showing you gamma B only. Gamma B and the solvent I will show you. One solute and the solvent. One of the solutes, one. So B I am showing. So if we follow, ln gamma B is just write, copy this plus, as you see here, epsilon B xb minus half xb square. Okay, then plus epsilon cc minus half x square. This term xd is 0. Substitute xd is 0 out, and this will be there. This will be plus. Write this. Let me write here. Here itself. Plus this term. Epsilon bc is what? xc minus xb xc, and this term xd out, xd 0 out, xd 0. This out. Okay. So this is, call it equation 5. And what is the corresponding ln gamma A? What is the corresponding? You can write ln gamma C, right? Similarly, I am not writing. Okay. I am writing the last one, this one. Okay. This does not exist. Ln gamma D does not exist. So ln gamma A is what? This is for solvent. You tell me minus half epsilon BB xb square. Just here you see minus half epsilon cc xc square. Okay, this is again out xd minus epsilon bc xb xc, and then this is xd is there out, xd is there out. So this is called 6, equation 6 for the ternary. Another will be there, ln gamma. Do yourself. Ln gamma c, do yourself. Acha, this okay. Third will be what next? You can guess. If it is 4 component, 3 component, then 2 component. For the binary system, AB, A solvent, B solute. Okay, again we have to put, what we have to put? What we have to put? Only no C, no D, XC is 0 and XD is 0. So XC is 0 and XD is 0 in equations. Okay, C and D will be out. They are not present in the system. These two out in equation 1 and equation 4. In equation 1 and 4. in equation 1 and 4. Okay. Equations 1 and 4. Okay. Let us put this and get this out. This one. Okay. To write this what? So this where it is? Here. Ln gamma b. Ln gamma b. Go ahead. Ln gamma b 0 plus epsilon bb xb minus half xb square and rest all out xc0 xd0 xc0 xd0. See, this is xc0 out, xd out, all out, only these two terms. Call it equation next. Call it equation what? 7 and what else? And ln gamma a from here, gamma a is what? Tell me. See, only minus half epsilon bb xb square out xc, out xd, out xc, out xd, out xc, xd, out. So this is, let me check actually, this that will be very good for the ternary. Ternary, let me check. Ln gamma bb xb minus half b plus xc is okay, plus bc xc minus xb xc. Okay, is okay. And ln gamma is minus half eb minus half bcc x square minus half bc eb xc. 5 6 is okay. 7 ln bb xb minus xc. Ln gamma minus half eb xb square. Call it equation what? Call it equation 7. Call it equation 8. Call it equation 5 6 7 8, and this is 7. Okay, 7 8. So total 8 equations. So this. So now I have to comment here. Equation 7 and 8. Note this. Equation 7 and 8. Actually, I don't want. Should I remove this? Should I remove this? This equation I will use today somewhere in the in the middle. I will use this, but I have to remove this. Okay. In case needed, I will write once more. Okay. Let me. I will remove this. So I remove all this. Oh, sorry. I should have not. Okay. Anyway, I need some space here. Okay. Star. So equations, concentrate on this binary which we have already discussed, and let us compare the relations we obtained there with modified regular solution, and today what we have. The same. They are exactly same. They are exactly the same. Okay, so equations what I should write? Equation 7 and 8. 7 and here are exactly identical to equations 4, not this 4, no, and equations 4 and 5. Equations 4 and 5 obtained where obtained previously last class, yes, last class, previously when you discuss binary solution and modified regular, and obtained previously in the last class. Please refer to equations 4 and 5 there, with 7 and 8 here. Same. After all this, okay. So this is actually good agreement, okay. So and we are satisfied that our procedure is perfect. So this is okay. What is this? Obtained previously with the binary solutions. Yes, with the binary solution AB. With the binary solution AB. Okay. So next, so we are happy. Okay, this consider this binary and the previously binary same. And this additionally we get quaternary and ternary. Good. So now at the concluding part, let me remove all this. All over. This is over. Okay. You remember these equations. Okay, or otherwise I'll write once more. For binary, remember I will refer to these equations. These equations. Okay, so this is okay. This will be. So last concluding part is this. Next, now you might be interested in 5-component system: iron, carbon, silicon, manganese, phosphorus, oxygen. Okay, so this may be 5-component. So for what will be for this is for 4-component ABCD. For ABCDE 5-component, predict we can easily predict following the sequence. If you follow the sequence, you can. Next, we can predict, and which is correct, we can predict, because this 4-component is exhaustively from first principle and direct done. So no lapse, no complaint, complete. This is a complete total first principle. Oh, so direct. Okay, as I have written at the beginning, it is direct, exhaustive, and self-sufficient. It actually follows first principle, self-sufficient. Okay, so next we can predict. Now following this, the results we can predict. Similarly, just extend the sequence, the pattern. We can predict following the trend, following the trend, following the trends in the trends in the binary, ternary, and quaternary, nary system relationships. We can predict what we can predict: the activity coefficient, the activity coefficient versus composition relationship relations in a 5-component system. 5-component system, namely which is that A, B, C, D, E. What is the prediction? Here is the prediction. Ln gamma B. Only one I am giving, gamma B. One of the solutes, gamma B. Is what? Later it is better I write actually ln gamma B 0 plus E BB XB minus half XB square plus epsilon, not E. E will come later. Epsilon. E will come later. Okay. Similarly, there is some similarity, but this is here. What is mole fraction here? There will be weight percent as a form of composition. And what is gamma here? That will be Henrian activity coefficient F. So later on, epsilon. If I say E, it is not E. Epsilon. Epsilon CC. Epsilon CC. Epsilon CC is okay. Epsilon BB CC plus epsilon DD. Oh, I'm very sorry. It is not like that. I'll check this. Minus half XC square. Oh, I don't know what happens. Minus half XC square plus epsilon DD minus half XD square plus epsilon EE minus half XE square, as you guess, XE square. Okay, this is, I'll write this okay later on. Plus EBC is what? XC minus XB XC plus epsilon BC BD is what? Tell me. XD minus XB XD plus epsilon BE what? XC minus XB XC. Okay, this is ternary. These are okay, 7. Okay, then what comes next is what? BC EBD EB. Then ECD is what? Minus XC XD plus ECE minus XC XE plus EDE minus XD XC. I'll just check. Okay, this is just with the answer. Okay, if I am correct, I will rewrite this. It's clumsy here, but correct, clumsy. But I will rewrite this. Okay, clearly. Okay. Well, let me check please. Then gamma 0 plus EPB XB minus okay ECC minus half is okay. EDD minus half XD square. EE minus half XC square. Then EBC XC minus XB XC. EBD XC minus XB XT plus EBE XC minus XBE. ECD minus XC XT. ECE XC XE plus epsilon. All epsilon. Epsilon DE is minus XT XC. Okay, correct. Okay, good. Okay, with this we have completed this. Okay, only thing I write this once more here. This one written here. Epsilon E E E E minus half x e square, like this. Epsilon dd minus half xd square, epsilon cc minus half x square, and epsilon e minus half x square. This is a test. So we have got this. This part is over. Now actually the question remains actually. Question or interesting questions, or it comes in your mind that how to find this interaction coefficients, self and ternary. Even gamma B0, which you know how to, well, gamma B0 is well introduced and we discussed. But still I repeat this for the sake of continuity. So gamma B0 and self interaction coefficients like epsilon BB and ternary interaction coefficients like epsilon BC. Just next job. Okay. So I remove all these things. Okay. So this is okay. This is all over. This quadratic relation not only we extended to the 5-component system also. So next topic is next topic is next how to this actually perhaps this actually okay this is actually is in your mind now. Okay, you are thinking about this how to find. You are inquisitive. No? How to find gamma B0 epsilon BB self interaction coefficients, epsilon BC for example, just example LBC ternary at a given temperature. This is actually these all relations at a given temperature, and if temperature changes, how activity coefficient changes with temperature, we have certain clues already. Okay, so regular solution behavior, or say we can go to the general behavior, universal behavior. I've given at a given temperature, at a given temperature, experimentally experimentally oh sorry experimentally okay, this is the question. First take gamma B0 first. This is very easy, but I will repeat this, but this is very interesting. What is this? This is first of all applicable to binary system. System applicable to binary system AB. Case 1. Case 1. What is this? When Henry's law, case 1, when under this there are two cases. When Henry's law is obeyed and when Henry's law is not obeyed. Okay? When Henry's law is obeyed, and which is shown in figure 1, is obeyed. See figure 1. So I will draw this figure 1 now. Okay? So I am removing all. This is a new thing. So you may underline this. Very important how to find this experimentally. So if you want to experimentally measure this, and which is a predictable job, these are data we borrow from books, literature, data books. But it will be very good, okay, very good that if we can find them out ourselves, experimentally measure them ourselves. Particularly new system for a new solid, say vanadium, carbon, etc., which are not available in literature. So the procedure is this, or there may be other procedures, but I am trying to. But this is simple. Now the question is simple. Gamma B0 is very easy. Here one. What is the figure? You just draw the figure. Draw the figure. I am drawing often this figure. Activity B, as you know, activity B, and this is XB, moves from 0 to 1. This moves from 0 to 1. We call this, I call this point O. This point is O. Okay, I will explain. First of all, here you plus connect this activity of B is, this is hard line. I am drawing hard line, hard line. This is the reference, Raoult's law. Activity of B is Raoult's law line. Just for reference. But we are discussing gamma. Okay. So activity. So first Henry's law. If Henry's law is applicable, you know there is a linear part which gradually or smoothly breaks into a non-linear. So like this. It's a linear, then gradually this may be actually picture. Okay. This is the non-ideal solution. Henry's law, Raoult's law, ideal solution, non-ideal solution. But important thing, there is a linear part initially, and gradually this changes into a non-linear. Okay, this is, and we are very interested in this linear part. And Henry's law formulates the equation for this law, gives the equation for this law. What is this? If we extend this linear part, as linear part, actually this pen is good, but I have actually sorry, it's disturbing, very disturbing. I once drew this. It's okay. So this is linear extrapolation. This is Henry's law. What is this? Henry's law line. Henry's law line. This linear part. Okay. I call this after this linear. This is linear OX. O, call this point. Sorry. X OX. OX. Okay. So this is what I have written here. OX. OX, OX, the linear segment. Segment dilute solution regime. This is dilute solution regime, where Henry's law is obeyed. So this is the Henry's law domain, okay, and this is the extrapolation, okay, theoretical extrapolation, just extrapolation, and we can comment here in this line what is the slope, what is that, and this line slope is what, how much is gamma b 0. This slope is gamma b0. We know this slope is gamma b0. We'll write this also here. Okay, slope is gamma b0. How it is? Note this here. So explain this further if there is anything to be explained further. So please follow this. So this is also line for reference. Okay, and all this in non-ideal solutions finally merge with the Raoult's law. So has merged. Okay. So initially, okay, Henry's law, and finally, when solute obeys Henry's law, solvent of Israel. So remember all this. So anyway, but not this actual. I have to draw another one for A also, but it is not required here. Only B our concern, and this is XB. Remember, this is XB. Why this is not behaving well? What's the problem? What's the problem here? XB 0 to 1. Okay. Now some note here. Achha. This slope, the slope, the slope of OX, the slope of OX, the slope of OX. Take up this. This is actually gamma b0. I'll show you. Is what? You tell me what is the slope of OX? DAB by DXP. OX. What is the value of XB is what? Any value within this domain. You see, this part is straight line. So any value dy dx, straight line, linear, any value XB is at Z. Sorry, what is I written? X. OX. Oof, this is giving trouble. Now it's okay. X. So at X or O or any intermediate points, anywhere, straight line. So XB is any value of XB, any value. Oh, this is okay. Any value of XB within OX. Obviously, this OX, the linear part. OX is the linear part. The rest is non-linear. Is what? How much it is? DAB by DXB. Can I write? Will you agree with me? If I write DAB over DXB anywhere between O and X, O is 0, XB is 0. So XB is 0, you don't mind anywhere, XB is 0. Is also AB by XB at XB is 0. Why? Dy dx is y by x. Because why it is true? For linear relation. Since ABXB is linear, so DAB by DXB is AB by XB. Like dy by dx is y by x. When y and x is a linear relation, like say y is mx. So y is mx linear. What is dy dx? M. What is y by x? Linear relation. Okay, this is okay. Okay, it's fine. Given this, then what is this? What is AB by XB is what? AB by XB known as gamma B. It's hampering. It's very much hampering with the progress of the class. Gamma B at XB is 0 and gamma B at XB is 0 is known as slope is, so this slope is gamma B 0. So that means what you have to do, how to get gamma B 0? Just activity, measure activity as a function of composition and plot, and then the slope, if it is Henry's law is obeyed, the slope of the initial linear part in the dilute regime, get the slope, and the slope is the gamma B0. So gamma B0 can be found out. Okay, but note, you might ask how to find activity. Who will give? Composition is very easy. Composition is very easy. 50%, 40%, 30%. You can follow the activity B. Then you know how to measure activity. Go by the definition. Now next point is note. You may ask, this is experimental. These are experimental. So activities AB may be measured by vapor pressure technique. What is the relation because this? What is this? Activity of I, the basic definition, fugacity ratio, which becomes finally vapor pressure ratio. When fugacity, when the vapor pressure is small, particularly, or approximately Pi by Pi 0. If we can measure the vapor pressure, okay, at the standard state and the state under study of the solution. Or what other method? Phase equilibrium, or phase equilibrium technique. What is that? A activity of I in the alpha phase is activity of I in the beta phase equilibrium. If you know in the beta phase activity of I, and you are interested to know activity of I in the alpha phase, then you use this equality. Okay, this relation, or this is phase equilibrium technique, or chemical equilibrium technique, or chemical equilibrium technique. What is in the chemical equilibrium? What you use? Equilibrium constant is activity of products multiplication, by activity of reactants. That in short, I am writing this principle. If you use, then the activity of the unknown can be found out using this. Or still another method is transport technique. Okay, this transport technique, etc., etc., etc. This is activity. So this part is over. Next, I will take up what? Case 2. Okay, sorry. How to find this? What is this? Case 1. Oh, this is case 1. Case 2 is what? This is case 1. Case 2. Case 2, when Henry's law is not obeyed. Case 2, which is when Henry's law is obeyed, as I have shown here. When Henry's law is not obeyed. And Henry's law is not obeyed. Figure 2. Figure 2. Okay. Let me teach this. Okay. One thing you might ask me, why sir Henry's law is not obeyed? Henry's law is there. So why it will not be obeyed? When it is not obeyed? If you follow very closely regular solution for simplicity or modified regular solution, which is practical, you will see. So one thing you tell me, the value of gamma b, as I told you, is AB by XP, at in this domain same. Gamma b is unchanged with composition. In this domain is gamma b 0, is same value. In this domain, gamma b is gamma b 0 for this composition. It is independent of composition. Remains same at gamma b 0 for this domain OX. So gamma b is not function of composition, but regular solution says gamma b. Just I'm writing short. I'll write here. But here ln gamma b is what? Regular solution alpha x square. What it says? Gamma b all the time changes with x, or for that matter xp. Composition. Ln gamma b changes with composition from very beginning for any value. As x changes, gamma b changes. Gamma can never be constant. So this is against this concept of Henry's law. But I will make a compromise at the end. Okay. So for the time I will remove. So let me give a note before I. Acha. Acha, okay. Let me draw this first of all. Then maybe I will go to the top. Draw this figure. Again similar. Oh, sorry. I am giving you the figure again. Activity of B. Like this. You have a 0 here, 1 here, and XB. Oh, by the way, you may write here. XB is 1 means what is this? Pure B. XB 0 means what? What is pure A? This is clear. XB is moving here. Same figure, a slight difference. 0, 1, and if you are interested, you may give a O here, like last time. This point is O. Origin is O. How much time? Okay, thank you. So this is again, as you do, draw a dotted. This is what? Raoult's law. Raoult's law line for reference. Now I am drawing actually. Right here it is pure A, pure B, binary. Gamma B0 refers to binary system AB. So now I refer to what? I will draw this. I will show you this curve. But this time there is no linear part when Henry's law is not obeyed. So what it will be like? It changes the slope all the time. This will be very difficult for me. Sorry. Let me draw this. I am drawing. We have to consider there is no linear. This is curve is from the very beginning. But this diagram I have to. Does it help you? Does it help? Okay, so no linear part. This have to, so let me write. This is, again you take a, here what we are doing here to get gamma b0. Draw a slope, take a slope, since it's a curve, all along curve, no linear. So take a slope at the origin. Origin means xb is 0, the point O. Take a slope. Shall I? Slope here. Slope here. So this is, let me write this. Okay, this slope, let me write here once more. Raoult's law line. What did it say? Henry's law not established. There is no linear part. All the time changing. Slope changing. Means curve is curve all the time. Okay, not established. So let us write also no linear behavior. No linear behavior. No linear behavior even in the dilute regime. Even in the dilute regime. Let alone the higher concentration. Henry's law is actually limited to dilute regime, but with linear behavior, activity versus composition. But this is not no linear. This slope taken at origin, this slope taken slope to the curve actually, to the curve actually, slope taken at the origin, slope taken at origin, so slope means, sorry, tangent, I am very sorry, slope of the tangent, slope, slope of the slope of a line, it is tangent here. This is already a straight line, it is tangent, slope of the tangent, sorry, the slope of the tangent to the curve, to the, which curve? AB versus XB, the real curve, non-ideal curve, with the AB versus XB curve to the tangent to the AB, and slope of the tangent, tangent to the at no, tangent drawn at the origin. What is the origin? At the origin, what is that? That is at, tell me, at O, that is XB is 0. Slope of the tangent drawn at the origin of the curve, of the AB XB curve. Okay, this is the AB. This is the AB XB. You draw a tangent at 0, XB is 0, which I have named O. This is the tangent. And the slope of the tangent is what? Gamma b0 I will show. This is, I will written here, I will write here, and this will be the answer to the question, gamma b0. So this is non-linear, so draw a tangent, the origin, very start, and the slope of that. So the slope of the tangent drawn at the origin. It was better, na? Drawn to the curve, it is better. Drawn, tangent drawn to the curve, drawn to the curve. Sorry. Drawn to the curve, tangent drawn to the curve. This is better perhaps. Drawn to the curve, to the AB XB curve, where at its origin. What is that? At its origin, what is this? That is at O. At O, which is means XB is 0. The slope of the tangent to the curve. That means what it is? DAB by DXB, DAB by DXB at what? XB is 0. Is the desired gamma B 0. I will establish this. I will establish this. This is answer. This how? But before this, I write a one line, one or two lines that why Henry's law will not be obeyed, or that why regular solution contradicts Henry's law. Like this. See, now start. What is the case 2? Okay. Note according to regular solution, I am answering why when Henry's law is not obeyed. According to the regular solution, or the modified regular solution, or the modified regular solution model for which what you need to call ln gamma b is alpha x square. According to this, gamma b always changes with composition. Changes with composition even in the dilute solution region. Even in the dilute solution regime. See clearly, always changes. X is 0. Ln gamma b is a x is 0 means xb is 1. That is the other end. Okay, when x is 1, when x is 1, ln gamma is alpha. That and gamma b will be actually it will be actually gamma b 0. And then as continuously x changes and gamma b changes. So So this is actually, let us follow this. This one I try to arrive at. So this clearly shows with composition continuously changes from the very beginning. From the very beginning, in the dilute solution regime, even so, note this. Even so, in this case also, in this case also, in this case of when Henry's law is not obeyed, in this case also, what is this? Gamma B0 is obtained as DAB by DXB. XB is 0, is obtained as this, which is XB is 0. Again, I have written here, but I have not proved yet. Normally, gamma B0 is AB by XB. Gamma is AB by XB, not D. DAB. So DAB works. DAB. For straight line region, here, dy dx is y by x. No problem. But here, gamma B is AB by, but this is DAB by DXB at XB0 will be gamma B0 is obtained as I am writing, which is mathematically established, below. I give a star here and go to the top. Okay. You may have this exercise you may find in the paper that I have mentioned. The paper, Dinabandhu Ghosh. Okay, that Metall's paper. The paper already I have cited. There also this part is given there. So you follow this. I'm actually giving you here also so that you have no difficulty understanding this. Okay, so I'm removing this. This part, this gamma B0 was still in the gamma B0, so I'm not remove. This will be good enough. Here, good enough. Follow this star. I'm still mathematically star. Follow this. I'm writing starting our conventional relation. AB is gamma B XP with universal relation. Okay. What is this? Then you are having or what is DAB is what? Gamma B DXB plus XB D gamma B, or DAB by DAB by DXB at XB is 0 is what? Gamma B at XB is 0. Why? Follow this. When XB is 0, this term drops. This term disappears. What remains here? So DAB by DXB is gamma B, and when it is XB is 0, under this condition, this also applies here. And this is known as what? This is the proof. You will get this proof in my paper that I have cited, but here this thing is written there. Exactly this. So DAB by DXB XB is 0 is also as good as gamma B0, and gamma B0 is conventional definition AB by XB at XB is 0. At XB is 0. So gamma B is 0. So this is this part. So finally, so we can conclude. So you see, in each case, here also, since it's linear, so this is applicable. Here also, both are applicable. DAB by DXB XB is 0 or AB by XB XB is 0 because it is linear as I have shown here. Y by X and dy by dx for linear sense. Next, so we can conclude So, so we can conclude that, we can conclude that, so we can conclude that gamma B0 is the AB over dxB at xB is 0. Okay. At xB is 0, gamma in all cases, irrespective of Henrian behavior, is obeyed obeyed or not. However, point still we use Henry's law. In case regular solution is not obeyed, Henry's law is obeyed. So, or supposing regular solution is obeyed or modified regular solution is obeyed, then this is. However, we still insist with the Henry's law. How? Explained here. However, we may consider that for small solute concentrations in the dilute solution, in the dilute solution, the AB versus XB relations relation is approximately, see this part, you see I have drawn this part is this part dilute rigid, this part is approximately linear. So not actually, this is not approximately linear means if it's not easy to, if you want to be very rigorous, or want to be is approximately linear, and hence approximately, and hence approximately obeys Henry's law. Underline approximately linear. But if you want to be exact, if you want to be punctilious, okay, if you want to be actually fully correct, okay, then there is actually this will be Henry's law will not be obeyed when the regular solution behavior is obeyed or modified regular solution behavior is obeyed. But we can approximately consider this part is approximately this part is linear. Okay. If you want to be dxb, dxb. dB by dxb. If you want to be meticulous, okay, if you want to be exact, then there is this is actually we call that the Henry's law is not obeyed if the regular solution is followed or modified regular solution is followed. Otherwise, if you consider approximation, then Henry's law, you will consider for this dilute regime. See, I can see here 51 minutes over. Whatever, well, 5 minutes maybe. So this 5, 6, 7, at the most 2 hours. At the most, between somewhere between now and then. Here, see this curve. Maybe this looks like linear, okay, but mathematically it is non-linear, okay. So we can approximate. So this part is over. Next is I will not be able to cover both of them. Self interaction coefficient quickly I will cover. This will not take much time quickly. So remove all this over. Okay, anything is left behind. Always Henry's law. Is okay. So remove this. Remove all. Clear. Remove this diagram. Remove all. Just last part. Gamma B0 is okay. So remove. Next is A will be B now. Quickly let us finish this at least. Self interaction coefficient A B B. In general I same species. Effect of B on B. Effect of mole fraction of B on gamma of B. Effect of mole fraction is what? D ln gamma B over del xb at xb is 0. Effect of B on B, self. So what is this? So name is self interaction coefficient. Again, you consider this applicable to, since you see B and A, of course, solvent there, say AB binary, applicable to binary system AB, where A is the solvent and B solute. From equation 7 today I have removed them, okay, for binary. Recall, from equation 7, I am writing this though, for the binary system AB, binary system AB, what we had, equation 7, we already have today, we already have today, we already have today. What is this? 7, if you go back to 7, this is written there. ln gamma B for binary, ln gamma B0. Remember, reduce 4 component reduced to 3, 3 reduced to 2, ln gamma B0 for the solute, plus EBB XB minus half XB square. Now quickly, okay, case 1 and case 2. Case 1, acha, case 1. Case 1, what is the case 1? Henry's law is obeyed. Okay. Case 1 is when, case 1, when Henry's law is obeyed. Let's consider this. Henry's law is obeyed. We will often consider Henry's law obeyed. Okay. But you understand what I said before. Henry's obeyed, maybe approximately obeyed or obeyed. Okay. That is AB XB relation is linear relation is linear in the dilute regime then what we have, gamma B unchanged in the gamma B is gamma B0 there, gamma B is gamma B0, or hence ln gamma B. Now I should change this. Hence ln gamma B is what? Ln gamma B0, and applying here, and this leads to gamma B, ln gamma B is ln gamma B0, and what? If these two are same, they cannot be 0. XB cannot be 0, so EBB is 1 hour 58 minutes. Okay, and EBB is 0. So in this case, when Henry's law obeyed, EBB is 0. Sometimes you will find ENN. Example, ENN is 0, but you will find E silicon is non-zero. E carbon is non-zero, but ENN is special. This I'll discuss later. But EBB is 0. Then in that case, you don't have to see if it is 0. Henry's law obeyed, EBB you don't have to measure. You don't have to find out experimentally. So case 2 is what? Last case, when Henry's law is not obeyed. When Henry's law is not obeyed, 5 minutes, 3-4 minutes, 5 minutes maximum is obeyed. 3-4 is obeyed. Then what happens? If it is not obeyed, then you know ln gamma B is not ln gamma B0. Ln gamma B is not gamma B0. Hence, and is not, and hence EBB is non-zero, and you have to find it. What it is? You have to find it. And in this case, EBB is to be experimentally experimentally for examples I tell you here is to be experimentally found out as follows. As follows. Example when it is like is silicon is non-zero. So these are okay, you can be okay. Other examples are there. I will give you later. So just example. So possible. Okay, it's not as follows. So how to find this quickly? Two figures quickly, very quickly. AB. This is the last thing today. 0 to 1, as you know, and you have XB 0 to 1. You call this point O point as before, and again you know AB XB. This is A. This is your B, and again you have this dotted line going towards Raoult's law. Reference Raoult's law. What is this? Suppose you have this, since it is not obeyed, so it will be no linear part, and this law is not obeyed. So from the very beginning, say this what? This is what? Suppose XB. Suppose you consider 3 points. 1, 2, 3 points you choose. 3 points XB. Then you plot from this. You are plotting ln gamma b. Gamma b. Okay. This is 0 here. These 3 points are here. This side is negative. Negative. This is what? This is called what? XB. Again, write XB goes to 0 to 1, A, B. Negative why? You see, when XB is 1, ln gamma b is ln 1 is 0. Ln 1 0. So ln 0, and when it is XB is less than 1, this is negative. It is negative value. Ln gamma b is negative. Okay, and what is this? When XB is 0, ln gamma b is known as, this is what? This is what? Ln, tell me what it is. This point is ln gamma b 0. Ln gamma b, ln gamma b 0. This XB is 0, ln gamma b is ln gamma b 0. Okay, this is negative. This is a negative direction. This is a 0. Okay, so ln gamma b gradually increases. So negative, this is actually negative deviation system. So gradually gamma b increases to 1, and ln 1 is 0. So this is negative to 0. Less than 1 to gradually to 1. So 0. So this is this. So what is this? What is the definition of this? Oh, okay, okay. Oh, I'm writing here. I'm writing here. By definition, sorry, very sorry. For me, it's okay, no problem. By definition, this I wrote, but I should write specifically what is EBB. You write, this is very important. Del ln gamma b by del xb, effect of b on b, as I told you. Effect of composition of b, mole fraction of b on activity coefficient of b, self. at xb is 0. You just this is the by definition EBB is this, and it is actually self-interaction applicable to binary system. Then start from equation 7 as I have already discussed. So please, so you how will you get this point? Now you have 3 points. Put 3 points here, here, here 3, and this point is we know it is actually gamma b0. So already gamma b0 I have already told you for now when this is not obeyed I have already discussed, and this I am writing you here. So note, this is called this figure 3a, and this is figure 3b, figure 3. Okay, 3b. Just note this slope here, right here. Here you take a, see, at 0, at xb is 0. Take a slope. Slope is what? Del ln gamma b by del xb at where? At the origin. The slope is taken at origin as required by the definition. Xb is 0. So this point at xb is 0. This is by definition is what? EBB. So what you are doing? Original plot is activity versus mole fraction. 3 points say. These 3 points obtain. Write this out. Note. Figure 3b is derived from figure 3b is derived from figure 3a. Figure 3a using gamma b0 is what? You know, recall for actually nonlinear situation. What I said? Del AB, tell me, by del XB at XB is 0. So here you will get this. Take this and get the gamma B0 as I have already discussed, gamma B0 part. So this point you will get. And this 3 point corresponding to this 3 point you will get what? Gamma. How will get correspond to this? What is the gamma? Here. What is gamma? By definition, activity divided by mole fraction. So get the gamma corresponding to the three compositions, put them here, and in the form of ln gamma b. In the form of ln gamma b, and we have these 3 things. Then you do one thing, you actually smoothly extend to xb is 0. Okay, this value is already there. So connect this, and then this curve, you draw a tangent to the curve at xb is 0, as it is xb is 0 means this point. Xb is 0 is this point. Okay, so this is a tangent. Okay, this is the slope of the tangent. Slope of the tangent. Slope of what? Is the tangent. Slope of the tangent. At which point? At here. At this. At xb is 0. Tangent to the curve at xb is 0. As required here. So what is this? Slope is d ln gamma b over dxb. Slope of at any point, and at the point is xb is 0. So this is by definition is EBB. So and we got it. So this is so one is using, so this point is using this from this curve, and other 3 points directly from this 3 points. So and write this out, and as I told you, what I told you, and so this point and these 3 points gamma b for the compositions, 3 corresponding compositions from here. By far, gamma b is activity value divided by xp value. So gamma b. So for these three. and take ln in the form of ln. So you got this, and so these panes are not okay cooperating. These panes are not cooperating, and what last, and gamma b is, as I told you for other points, gamma b is ab by, these are, remember, these are all experimental points. Okay, gamma b is ab by xb for the other xb values. So get the gamma b from this and get ln gamma b corresponding the compositions and place them and draw this, okay, draw this segment